Yes, so I think we had a really great group and made a lot of progress in the limited time that we had. And we're utilizing data from the Ocean Observatories Initiative, short OOI. And one of the arrays that goes into this OOI network is the Pioneer Array, which is located in the Northwest Atlantic across the shelf break. And it consists of 7 moorings and moored profilers, which are indicated here, and then additionally gliders that are kind of sampling a larger area. And one of the objectives was to use these 4 vertical profilers here to plot a horizontal section across the shelf break. And at the shelf break, you have the so-called shelf break front, which separates the warmer, saltier water offshore from the fresher, cooler water inshore. And yeah, a lot of people are interested in the variability of this shelf break front. So the first step was to download this data for the 4 profilers and load them into an X array, which we have done successfully. And then the next step was to just, first of all, visualize the data that we have using Python and visualizing it with the data being in an X array. And these are just 2 example profilers. They're called inshore and central inshore. And this is the full time series, which roughly spans over 2 weeks for this one profiler, just as a scatter plot. So you can already see that you have some variability of how deep this profiler goes with each profile and how shallow, and then there's some data gaps. And for another profiler, this might look completely different. It goes to a different depth. And if you zoom in also, like here on the right, you can see the individual upcasts and downcasts. And in this inshore case, the upcast is not as long, or it starts at shallower depth. Then the downcast goes deeper, and then on another mooring, the central inshore, they're kind of more similar. So one of the challenges is to kind of match these profilers in depth and time so that we can ultimately plot a section across all of these profilers. So as a next step, we decided to split the casts into an upcast and a downcast, and also to be able to separate them into individual profiles, which we were able to do, like we've shown here on the left. And on the right is just an example of one of the profilers where we only show the downcast and only the upcast. And you can see that in the upcast, you're kind of losing a lot of data because it's not always going to full depth. Whereas the downcast seems sort of okay for this profiler. And an ultimate goal was to put all of these profilers into 2D X arrays that have the same dimensions, so the same depth binning and also the same binning in time, so that we can just select a time step at which we can plot this horizontal section across the shelf break front. So we did a vertical binning of each profile and smoothed it a little bit, which worked well. And as a next step, people have been starting working and visualizing profiles of these first, of these 4 profilers, like it's done here. So you can see the blue line indicates the bathymetry. So we have the shelf break here and then the continental slope. And we're visualizing here salinity on the top and temperature at the bottom. And one of the future goals is then to kind of do some horizontal interpolation to visualize this section nicely, and then to kind of locate this shelf break front and mark it in these sections. And at the moment, yeah, we are in the process of creating still these 2D X arrays that then can be fed into this plotting routine. Yeah, and I think the ultimate goal is to provide a tool for people that are not so familiar working with this data, just a visualization tool so people can run the code, plot the profilers, and see what the shelf break func's doing. I hope that was 5 minutes.
You're 5 seconds over.
Oh, okay.
Perfect. Yeah, thank you so much. So we have one question, which is, what package was used for the plots? They look nice. Is it Plotly?
No, it's just matplotlib, and then the Seaborn package, I think it's loaded. So the Seaborn package gives it this gray kind of background